I have here the states data set open, and we are looking at a frequency distribution of WIM-LEG 2015, which is the percent of women state legislators in the year 2015. What's interesting about this variable is how much it varies. You can see a state here that only 12.5% of the state legislators are female. There are quite a few states in that lower range. All the way down to the low 40s here, 42% in one state were of female legislators. I wonder why this varies so much. What are some possible causes of this? Suppose a student of state politics theorizes that education might be a factor. That is, as a percentage of a state's college graduates goes up, the percentage of female legislators would also go up. Perhaps a cultural variable works in the opposite direction. This student theorizes that as the percentage of frequent church attenders in the state increases, the percentage of female legislators will decrease. A correlation analysis is a good place to start when you're just investigating the overall relationships between interesting variables. Let's obtain a correlation analysis of these three variables. Percentage of women legislators, that's the dependent, and then the two independents, a 10%, and a percentage with a BA or more in the state. Go down to correlate, go right over to bivariate. I've already set that up from previous analysis. Let's redo it. Here's a 10%, that's the religiosity variable. BA or more, that's the percentage with the college education in the state. Those are the two independent variables. Let's go down to the bottom and pick up WIM-LEG 2015, the percentage of state legislators who are female, and we'll click OK. The output includes a correlation matrix. There are 6 correlations inside the matrix. They're repeated. The matrix here shows the bivariate relations between all the variables, and they're repeated down here below the diagonal. Let's locate the dependent variable here, WIM-LEG 2015, percent women state legislators. This relationship, minus 0.716, is the correlation between frequent religious attenders and female legislators. And this is a fairly strong negative association. We know it's negative because it has a negative sign. As a percentage of attenders goes up, the percentage of female legislators goes down. And we know it's pretty strong because correlations vary or can range from -1, which is a perfectly negative relationship, through 0, which is no relationship, to +1, which is a perfectly positive relationship. So here we have a fairly strong negative. Over here, as hypothesized, we have a positive relationship between the percentage of college graduates and female legislators. This is a positive correlation, 0.593, moderately strong at that. This tells us that, yes indeed, as college graduates goes up, percentage of female legislators also goes up. So we have a couple of things going on here. Notice for future reference, though, that there's a negative, a fairly strong, moderately strong negative relationship between the two independent variables. Minus 0.519. Thus, as the percentage of college graduates increases, here, the percentage of frequent attenders declines. What this means for future reference is this: as the percentage of college graduates increases, the percentage of frequent attenders declines, and as we compare states with fewer college graduates to states with more college graduates, we are also comparing states with more frequent attenders to states with fewer frequent attenders. So both these variables are working together, and when we do multiple regression, we'll try to sort out the partial effects of each one.